So before we jump more into it, I will give some introduction of application of system Pulley. What is Pulley? Pulley system are simple machines that plays an important role in the reduction of effort to lift or move heavy load. Comprising wheels and rope or cable, Pulley system facilitate the reduction and distribution of force. Ancient and modern engineering utilize pulley system in everything from lifting building material at building construction site to manual lift, crane and elevator. With different configurations such as fixed, movable or compound pulley, the mechanical advantage can enable user to lift heavier load with a smaller force. Aside from being productive in construction and industry, these systems are also essential in real applications such as sailing, rescue, and warehouse operation. It is significant to understand the physics of pulley systems such as force, work, and efficiency in order to properly utilize them in real-world problem solving.
Here are the problem statement for the application of pulley system. A worker named Arif used a double pulley system to lift an item to a certain platform. He pulled the 100 kg metal barrel to the platform located 12 meters from the ground in 20 seconds. Question 1. Calculate the actual weight of the metal barrel. Question 2. Find the acceleration to lift 100 kg in 20 seconds. Question 3. Calculate the work done by the worker to lift 100 kg load using pulley system. And last question, how much force does the worker use to lift a 100 kg load using a pulley?
Solution for question 1. Firstly, we will write the formula, and the formula that we use is W equal to mg, which W is weight, M is mass, and G is gravitational force. Second, we substitute the value into the formula. We are given mass equal to 100 kg and G equal to 9.81. So the formula W equal to 100 times 9.81. So the answer is 981 Newton. So the actual weight that we get is 981 Newton.
To solving the question 2, first step, we need to write the formula first. The formula is S equal to ut plus 1 over 2 at squared. The second step, we need to substitute the value. From the problem statement before, we are given the S is 12 meter, T is 20 seconds, and U is 0. And then we plug in the value into our formula, and we get 12 equal to 0 times 20 plus 1 over 2 A times 20 squared. And then we times 1 over 2 A with 20 square, and we get 200 A. To find the A, we need to divide 12 with 200, and we get A is 0.06 ms.
Solution for question 3. The first step is we need to write the formula that we stated before, which is W equals to M times G times H, and then we substitute the value given. So we are given mass equals to 100 kg, gravity equals to 9.81 meter per second square, and height equals to 12 meter. And then the formula will be W equals to 100 times 9.81 times 12, and then the answer will be 11,772 joule. So we get the value of total work done is 11,772 joule. The last one will be the solution for question 4. Same as before, we write the formula, which is F equals to M times A. Next is we need to modify a bit the formula. It becomes F equals to M times A plus W. You all must be thinking, why do we need to modify the formula by put the value of W in the formula? The answer is simple. It is because the object is moving against gravity. This is a situation where the load is being lifted upward and there is an acceleration upward. The worker must overcome two main resistance. The first one is gravitational force, or considered as U. The formula is W equals to mg. This is the minimum force needed just to hold the load in place or move it upward at constant speed. Next is additional force to accelerate the loop. The formula is net force equals to M times A. If the load is accelerating upward, the worker also needs to supply extra force to cause that acceleration. So, the total force required is total force equals to mg plus mk. Now, moving back to the question 4, we substitute all the value given. We are given mass equals to 100 kg and acceleration moving upward equals to 0.06 meter per second squared. Then, final value will be 987 N. So, we get the value of total force the worker need to lift the metal barrel is 987 Newton.
To conclude application of system pulley. Overall, pulley systems are simple mechanical devices that really enhance our ability to lift and move heavy load with reduced force. Their applications are far-reaching, from building site and rescue operation to factory equipment and daily tools. By understanding the elementary physics involved, such as force, mechanical advantage, and efficiency, pulley system can be applied effectively and safely in practical application. Mastering how to utilize them efficiently not only leads to improved mechanical design and less labor-intensive process, but also foster problem solving and innovation in technology and engineering.